talked about everyday forces, and today we are going to continue that discussion. But first, we're going to do a quick review. What is weight and what is the normal force? Hopefully all of you remember from last time that weight is not mass, it is totally different. And the weight is the force of gravity acting on an object. So we take the mass of the object and multiply by the acceleration due to gravity, which is negative 9.8 meters per second squared on Earth. And what is the normal force? Normal force is whatever counteracts an object's weight when it is sitting on a surface. So it counteracts the force of gravity when an object is on a surface. And remember, the normal force for an object is always equal to the force of gravity unless that surface is breaking. Ignore the whining. Bexley just wants to go run around outside, but he's fine. So when an object is on an inclined plane, we have to think of the normal force a little bit differently. Because before, we would have the force of gravity pointing down and the normal force pointing up to counteract that. But on an inclined plane, things get a little funky. Gravity, remember, always pulls down toward the center of the Earth, right here. But the normal force is always perpendicular to the plane. And perpendicular means it forms a 90-degree angle with whatever surface it's sitting on. So this is the normal force. Normal force is there, and gravity is here. So it gets a little weird. So we have to break gravity into components. Remember, we have the x part of gravity and the y part of gravity. But the normal force is already on our new y-axis, right? This is our new y, and this is our new x. And the normal force is already on our new y, so we don't have to break that down at all. So just remember, anytime you have an object on an inclined plane, the normal force is perpendicular to that plane. So this is how we do it. We have the normal force pointing perpendicular, and we have gravity pointing straight down. And our new axes are here for our x, and here for our y. So we need to break down this force of gravity into its x component right here and its y component right here. So now we can do the sum of the forces in each direction. Remember, we can only add up and downs together, and we can only add side to sides together. We cannot add those two, side to side and up and down, together. That's not okay. So the sum of the forces in our y are the normal force, which is pointing up, so it is positive, and the y component of the force of gravity, which we'll call FGY. And there are no other forces acting in the y direction here. Now let's do x. We have the sum of the forces in our x direction are, well, there's only one. We have the force of gravity in the x. And you can see, it's kind of hard to tell from here, but the y component of gravity is acting down. The x component of gravity is acting over to the right, so it is positive. So it may look kind of strange because we have two y forces and only one x force. Well, it turns out in just a second, I am going to introduce to you another x force that we haven't talked about yet, but we all have experience with. But before that, I want to show you what your homework is for tonight. So after you watch this video, read this page underneath the video and answer these questions. How much force is required to start a 1 kilogram block of wood moving on a wood table? And how much force is required to keep that block moving at a constant speed? So you won't be able to answer these questions yet because we have to talk about our new x direction force, which is friction. So what I want you to do right now is get out a piece of paper and write down a couple sentences describing friction. And I am actually going to wait in this video for you to do that. So go ahead, pull out a piece of paper, describe friction, or do it in your head. Okay, so hopefully you have a couple sentences describing friction, and I want you to compare what you came up with to this definition. Friction, which we label big F, little f, so it's the force of friction, is a force that is present when two objects are in contact with each other. So it is a contact force. It's due to molecular interactions between the two surfaces, and it is always present even on very smooth surfaces. It's really difficult to get a surface that has zero friction. There are two different kinds of friction we'll talk about in this class. Technically there are three kinds, but we're really only going to focus on two. Kinetic friction is friction between two objects when there is motion between them. So when something is moving relative to the other. And the other one is static friction. And this is friction between two objects when there is no motion between them. So the force of static friction between two objects is generally higher than the force of kinetic friction between the same two objects. And this is because static friction is what keeps an object moving initially. So if you're on a carpet and you have a really heavy box on the carpet and you want to push it across the room, if you push gently, the force you're applying to the box is not big enough to overcome the static friction. The static friction is when that box is not moving, and it's keeping that box from moving. And the kinetic friction is the friction between the box and the carpet once you finally get it moving across the room. Friction is related to the normal force, it turns out. Most people would think that friction is related to the weight of the object, but it's actually related to the normal force. But if you remember, normal force is also kind of related to the weight of an object. So the equation for friction is force of friction is equal to mu, this is the Greek letter mu, times the normal force. So what the heck is mu? It's like a little U with a tail on it. Well, it is a Greek letter, and it is the coefficient of friction. There's a static coefficient of friction for objects when they're not in motion, and that is mu little s. And a kinetic coefficient for objects that are in motion, which is mu little k. And it's these coefficients that relate the normal force to the frictional force. And don't worry, you won't ever have to know any of the coefficients of friction off the top of your head. You will either look them up in a table to use them in this kind of problem, or you'll be solving for them. But you won't have to memorize any of these. So when we zoom in to that box on that carpet that you're pushing across the room, on a microscopic scale, the surfaces are rough. The exact details aren't known yet, but the force can be modeled in a simple way. For kinetic friction, we write the force of friction is equal to the kinetic coefficient of friction times the normal force. And remember, mu little k is the coefficient of kinetic friction, and it's different for every surface. So this is where you would look up those values. So, for example, if you want to know what the coefficient of static friction is for ice moving on ice, we would go over here to the kinetic friction, and it's 0.03. That's not very big. The smaller the coefficient of friction, the less friction there will be. The easier it is for those things to slide across each other. On the other hand, static friction is the frictional force between two surfaces when they're not moving. And static friction keeps objects on inclines from sliding and keeps objects from moving when a force is first applied. Like the box example, eventually you get the box moving across the floor, but you have to push harder and harder initially to overcome the static friction between the box and the carpet. You also see things like this when you have a block of wood on another block of wood, and you can tilt the second block of wood and the first one stays there. It doesn't move. At a certain point, it will roll off because at that point, the force of gravity has overcome the force of static friction. But until that top block starts moving, the force of static friction is greater than the force of gravity pulling on that top block. So the static frictional force increases as the applied force increases. So that means for the box on the floor, you start pushing right here. This is where you apply a force. And at first you don't push very hard, right? Your applied force is pretty small. But then you push harder and harder and harder and it still isn't moving. So you push harder and harder and harder and it still isn't moving, this darn box. So you push harder and harder and harder, and then all of a sudden it starts moving across the floor. And it turns out once that box starts moving and we have changed from static friction to kinetic friction, it's slightly easier to push this box. You had to push harder to get it moving than you do to keep it moving. When an object is sliding down an incline, like a block on a block, as in the picture, this object has three forces acting on it. Remember, we already talked about the normal force, and it's always perpendicular or at a 90-degree angle to the plane. We have the force of gravity, which always pulls down toward the center of the Earth, so it's going to look all wonky here. It doesn't fit into our new X and Y coordinates. And the third force that is always acting on it is friction. And friction is parallel to the surface, always. So now we have our normal force in the Y, we have our frictional force in the X, and we have our force of gravity, which is technically in both. It has a Y and an X. And remember, frictional force is pointing up, so it is positive. Normal force is pointing up, so it's positive. Sorry. Frictional force, however, is pointing back, kind of toward the left, and we call this a negative force. And gravity has a negative Y and a positive X. So if we were to do the sum of the forces here, the sum of the forces in the Y are going to be the same as they were for the very first slide in this video. We have our normal force in the positive Y direction and a negative force of gravity in the Y direction. The forces in the X are going to be a little bit different. We still have a positive force of gravity in the X, but now we have a negative force of friction. So anytime you do an inclined plane problem like this, make sure you have all four of these forces. You need normal force, Y component of gravity, X component of gravity, and the frictional force. So So now that you know a little bit about what friction is, go back to the questions, the homework questions, and try and answer those the best you can, and bring them into class the next time I see you.